Okay, I've placed in the spacers and the hand crank and the spool, and I've constrained them. At least I've constrained the axis of the hand crank to be aligned with the axis of the axle, and I have made these flush. Put the spacers in. Here and here there's an 1/8 inch thick spacer here and a 1/2 inch thick spacer here. And so now what we could do is constrain this face with this face here. The purpose of the spacers is to ensure that the face of this 3D print does not rub against both the inner and the outer race simultaneously. That also defines, how far this axle sticks out from the bearing. And we'll do the same thing on this side. We'll go constrain this inner race here with this spacer. So everything is axially constrained, but notice when I grab the spool, it turns, and I can turn that, but nothing else turns. Really what should happen is the axle should turn, and also the gear would end up turning in real life as well. And so even though those constraints may not be necessary for someone to know how to assemble it, I do want to show you how you can get those constrained. So one way that I do this, and there's probably more than one way to do this, but I just use the angle constraint, and then I select an edge like this, and notice it gives me a little vector arrow. You see that arrow there? And then I can select an edge here, and it gives me an arrow as well. And all I really need to do is go just directed angle, and by default it sets it at 0, and basically the arrow here is now parallel with the arrow there. And so if I go apply and turn this, the axle now turns with the actual spool. I could do that with the gear. Now I can't really access and view the gear hexagon, and so what you can do is just select the part that you want to hide and right click and go visibility, and I can hide maybe these parts here. So now I'm hiding the bearing and that plate so I can get a better view of the hexagon on that axle. So I can go angle, click here, then I want that on the axle or on the spool. It really doesn't matter. I can choose the edge of the spool because I want them aligned. And if I hit directed angle, notice this arrow here of the spool is lined up with this arrow here of the gear, and then I hit apply. And so now when I turn the spool, it turns the axle, and it also turns the gear. Now I can do the same thing here. This really would be aligned with the axle as well, so I'm just going to go constrain, angle, choose that, and then choose some other flat edge that I want it to be aligned with, either with the axle or with the gear. And since it's a hexagon, it will just rotate and clock that spacer to meet the constraint that I'm adding. And then I can hit OK, and now everything rotates, and everything you can see the actual spacer rotates as well, and everything is aligned on the hexagon as you would experience in real life. And so you can do the same thing with this. You can do the same thing with this handle here, this spacer, and this gear. But what we also want is when the top handle turns, we want it to turn this gear, of course, but we also want it to turn the spool. So let me just go through that really quick. I'm just going to go constrain and get the handle with the axle. I'm going to hide the bearing in this plate, and I'm going to go constrain, angular constraint, this with this. Angle is 0. I'm not going to do the spacer right now, but I do want to show how you can do the gears. And typically what I do is rotate the gears so that the teeth are meshed here properly, that they're not running into each other like this. We will talk more about these types of spur gears and how you can actually design them yourselves instead of just being provided the gear. But these spur gear teeth interact, that they push against one another at a specific point. And so I'm just going to have them meshed like this, and then I'm going to make a certain motional constraint. And this is a 24 tooth gear and a 52 tooth gear. And you do need to know the number of teeth to do this properly. And you go constrain, motion. We know that if this gear turns one direction, the other gear is going to rotate the other direction. And so I'm going to do a reversed. And the first gear I click is going to be here. And it's kind of hard to see, but you can see that there's, let me rotate it a little bit. You can see that there's a directed arrow. That's the curved little arrow is going counterclockwise around the vector that points out like this. And if I go here, the arrow is now clockwise. And so basically, if this one spins in one direction, the other gear will spin in the other direction. So they're reversed. But the ratio is not 1 to 1. Basically, the ratio of these two gears rotating is going to be the ratio of the number of teeth. And so I need to go 24 divided by 52 and then hit apply. Now I'm going to just make all the parts visible again that I made invisible. So I'm going to go right click, visibility, bring those back. And if all goes well, when I turn the crank here, it should turn the lower gear and in turn turn the lower axle and the spool on the other side. And you can see that the teeth remain meshed.